My name is Erik Skytthe. I'm working at DBC, which is a public library firm in Denmark. I've only been there for 1.5 years. I have changed my title a little. It was attacking production problem. It went more into be investigating. It's more be like Sherlock Holmes. This I found out. It's not being like a show though. Okay. So how we? Oh, I can use this one. So how go? So how it's working? Like this? Okay. Yep. Just this we have to go through. So we are a public firm. We have a central databases of all majors at public libraries and technical libraries in Denmark. So that's from books, CDs, Blu-ray CDs, everything. Also a lot of articles from internet, and that all these things we have in several databases. One database is for where professional librarian people can go down and look in it. They have all requirements than the usually ordinary Dane person. Also, old Danes can go in and look in these databases, and they can find some books they want to lend and click in and get it to their home, actually, or the library near them. We are dealing with open source. We're using a lot of the most as we can. We are using open source tools, and we also our own work is also put out as open source. Yeah, you can get this later, and you can look at that. This library world is a bit like to be on another planet. Librarian people are really special people. As I wrote here, if librarian people, if you ask librarian people to search for something, they will use all fields at all they can. It's not like us who just take out Google and take it. And sometimes, yeah, you can get even that you can find the books in the system. Well, it could be a long way to get these things. Yeah, I put some comic on because you're sleepy, I think, so you can at least look at these. I have 5 main production problem I was facing when I was joining the firm, and I'm going to do a little talk about each. The first problem was a lot of dead and service not working, and it was all over the day at special times. No figure in how it was. We didn't know when and why. No clue at all what it was. Well, somebody was talking about network and things like that. And it was also a system which didn't have relationship to each other. So that was the strange things about that. That's why we were calling it the ghost case. Later we'll find that there was actually the central firewalls, which was the problem here. The root case was that the firewall wasn't set up to. There was too many connections going through it. And the reason why we're getting all these connections through the firewall, and we haven't seen this problem before, is that we was in a phase developing a new system. A new system was based more on web services and IX call, and so one session, one browser opens could generate 10 or 20 sessions. And there was also a bug in one of the software. I will come back to that. And that was the reason that our connection table in the firewalls, the connection have increased really, really much. And so when the firewall was getting into this limit, it was just cut connections. And that was the reason we were seeing all these outages and problems. And we were doing, we were putting on some monitoring in Zabbix, and we could follow the how it was, when it was happening. Now this is a later graph when we have solved the problem, but also just to show you if you have a graph or over your connection, it could be, you also can see, well, here is a drop down, so this could also increase point at some problems. So it's both ways, if you understand. Yep. When we were founding this problem, we suddenly I was fast putting up just SMP or monitoring of the connection in the firewall, and it was really good. We had this graph because several times we were just increasing it some amount first, and then we were seeing we were hitting it again, and we were also getting some alarms on it. And that was because sometimes our developers was running some heavy tests, and then it could kind of doubles. So that's really helped us to kind of figure out what's happening, to have this baseline on it. Actually, there's 2 or 3 continuous stories about this ghost case, because shortly after that, I was starting to put up some syslog monitoring, and suddenly this was I was remarking this in the syslog, and that was because of some of the web hosts who was hosting these applications. They actually also was falling into a problem with connections, with the connection tables. So here we also have to increase the amount of connections. Here it was the local firewalls on these hosts. So good things is to put up syslog, also rsyslog, like the other fellows before he was talking about. Have a some good things in it. It's really easy to filter in. I also have just in some screens in Zabbix, I put also the essential syslog things we are seeing. I just made a screen with a URL. It's really easy. It's really easy to navigate, and my fellow people, they don't remember the URLs I sent to them. So I just put this up, and they can just look at that. Let's see. Yeah. Actually, we were doing some upgrade of some of the central web servers, and on the OS side, and actually figure out that the new OS it had to do with some of the kernel parameters. It was set in another way, so we were going into this problem again, and what we were seeing was that because we have this graph, we could see, okay, this is not good, and we have to fix it with some parameters changes in the kernel. And we also find that these applications, they didn't when they were running the sessions, they didn't free the sessions, so they just kind of or did not they did not reuse the session the sockets. So the sockets are just increased all the time, and actually here you can see the developer have fixed this problem with not reusing the sockets, and that's nice to have a graph to kind of see. Okay, now it's working okay. Yep. Then we was running into what we call the what I call the Java case. The victim was seeing dead Java applications, and it was not really nice because it was a new central system, and customers were not really happy, and the management wasn't too. And we didn't know who to suspect, and evidence, big Java log files to look in, and the developer was, hey, what do we have to look in, and when do it happen, and things like that. Well, we were implementing some more Zabbix here, and I was using this this Zabbix bridge. Now, of course, there's Java is integrated in the 2.02, but we're using this, and we were finding when this was happening. From the graph, we could find out when it's happening. I'm sorry about this old graph because the data in this case I couldn't find the data because it was kind of the data have go into trend periods. So I couldn't really get down to the details, so I have to kind of show how the graph seems. Used to seems, and it was really like this. You have a graph, and then in for 30 minutes, it will go like that for some of the Java attributes, and then it will fall back when we have rebooted, and it will go down there, and there will be a gap here. We were making a trigger and with 30%, so we at least could see when was okay. Now it's beginning to go up, and we have to interfere with it. And we were also using the graph, as I was saying, to point out to developers when is this happening. So. Actually, in that way, they were found out in the log traces and things like that. They were found out that it was because of an internal update routine. It was not handled timeout very good. So this routine was running, and there was it was actually updating of a data store. And sometimes its data say, "Oh, I can't get more data, and you have to wait." But this, so it actually was making a timeout. But this routine didn't handle this timeout, so it was just starting the search again, and it was actually accumulating the search because it was asking for what it was asking before, and all the things it haven't, and put all the things it didn't get answer on. So it's kind of getting bigger and bigger, this search. And then finally the whole system was going down. But in this way, we were using the graphic and the graphs to show out what the problem was. Today we also, it's just a side, we use, we have made our own attributes in Javas, and we make our own templates we're using this Solar system for search, and in this way we kind of put out and get out production data. It's it's nice. You can just go down and the developers say, oh well, we need this figure. We just develop that in Java, and you can go and ask for that. Actually, we kind of. This was just some, well, now we were going in a more phase. We were getting Zabbix more rolled out and on all production servers and things like that. And I was doing some development, and with one of my colleagues, we were discovering that many of the applications we were running actually was doing rather well logging. They're doing a logging of every transactions, and the format was also nearly the same. So we were developing a script to pass these log files. In that, and it was developed to because it was big log files. We're running this script, and it kind of take from behind and read, for example, if you can say specify the seconds. So I specify, for example, 5 minutes or 1 minute, and I want to get the log and run this as a cron job every 5 minutes, and get all the data here. Connecting these, sampling all these data with errors, average transactions, and whatever we want to get out of the logs or can get out of the log. We send it to the Zabbix server with Zabbix sender. It's a really good picture. Thank you for that. And then in that way, we were actually rather easy able to get production data right into Zabbix. And I think for us it was a big moment when we were doing this, because I have worked with a lot of other monitoring tools, a lot of commercial tools, and a lot of times we were just in these projects we have just only get until OS and never getting to this stage where we're also beginning to get application data inside. So that was really nice. In this way we could, this is one of our main graph. We have on this side over there, can I use this one? Ah, yeah. On this side, we can see the average time. Well, this is Danish service, but I'll translate the average time for transactions. And we have one transaction. We have a trigger for about 8 seconds. It's not allowed to take average more than 8 seconds. So we can use this graph to see. Okay, here we get over to up to 45 seconds and something like that in 2 peaks. We have another graph here. That's the amount of transactions, and that's on this side here. So we can see, okay, this don't seem to have any matter with the amount of the transaction. Don't seem to have any matter with when we get bad response times. Another thing we did was that I was a workshop with one of my colleagues, and he was showing me this utility. This is some old own developed in my firm. But the good thing was that feeding this utilities with some values, you could make the same test again and again. So I was making a little script. This is the utility, and I just put it in an input file, and it will give me out for example 5 or 6 steps here, and I could just grab on the elapsed time, and in that way I could get the time out. So I could, in this way, I'm running. We're running each moment, each minute. We're running this test, and it's testing our back-end systems. And I'm doing the same test over and over again. And in this way, I put up the back-end systems in 5 or 6 different subsystems, you can say, and I can follow. Well, it's okay or not okay? I'll go back. And you get this stack graph, and can see when you we'll get back in that later, because you will see it in some of my other graphs. Just a smaller presentation on how we we have. Yep. Or maybe jump to this one. Actually, the way I'm working when I'm going to investigating these rather big problems we was having, I'm using the Zabbix screen tool. That's my workboard. So I combinate. I try to get a lot of data from logs, from scripts, from polling, from Zabbix tables maybe, or whatever. And I combine these to different graphs. I move around with them, play with them, zoom in and out, try to make overviews, try to combine different things. In this way, I try to analyze and looking for trends, try to find patterns and correlate graph, and try to isolate the problem. So that's one example. I just put up all the CPU times for all the systems in I think it's some of our backend system here, and I combine it with the tools I had before, and which is showing the backend subsystems. In this way, I have a fast overview, or okay, there's some peak here, but Well, nothing to see, so it don't seem to be CPU related or I/O or something like that. In that way, I get a really fast overview about that. Another one, and that's what I mainly do. I put the graph under each other, try to correlate. Is there something here which you can see here or here or here? What I do here is it was the first graph I was showing, which showed the transaction data and the times. Well, it's a bit small here, so you may not can see the detail. And here I have the graph from the backend systems, and here I have, I think it's some of the search engines or our database, just to see say no relations to problems. Another one actually here I put up two main database system. No, not search system we have, which kind of twins, but I'm monitoring the same way, having some network also, and some here I have we were facing some problems with we thought we was facing problems with our database servers and system time, so I'm looking at that here. So when I was searching, I was putting all up these windows or screens, and sometimes I was putting another one in and like that. What we go into now is, well, this is you. You're not paying attention, aren't you? You're sleeping. No, okay. Sorry. Now we go to what I call the Wednesday monster, where I call these three last problems we were facing the monster problems, because it was three really big problems, mainly performance problems. So what we were seeing every Wednesday morning, typical, we were having some major performance problems. And subject, back-end, front system, we didn't know. We're trying to look into the trending graph and monitoring alarms. So here we're seeing, that was the graph from before. We're seeing the amount of transactions, and we're seeing the average response time of all the transactions. So here we have a collation, and now I put and that's going down here. So here we can see that's the backend system we are looking at. Okay, so don't seems like any problems with the backend systems, but utilization here, well, that's really kind of correlate here. So you are really sleepy if you don't can see that. So what we see is major increase in the amount of transactions per period, and there's really a big correlation here, heavy CPU's time. So, well, yeah, just what I was saying. And our conclusion, we were looking at the twin system, didn't see any problems there. So we were facing the other systems mainly. There was not. So this was saying, well, that was kind of our problem isolation. This is not a general infrastructure problems. That's something with only this system, maybe the front-end system. And I zoomed out, looking. Okay, so every Wednesday, you can see here the gray fields is weekends, and this is in the night, the other grays, and the light fields is in daytime. So that's also a good picture of this, because it's really fast to tell you, hey, well, how are we, where are we? So every Wednesday, well, a lot of transaction, it seems. Well, it's standing here in Danish, but I say it's transaction. I was looking more into it. It's bulk. Also a lot of transaction. I was making a top 10 here, and rather a lot of the actually we can see it here. Actually, up to 40% of the transaction was in these top 10. Well, that's amazing. I was taking one of the top 10 sources, And also see here that that's the amount of transaction they're doing. They make in a week, and every Wednesday. Wow, okay, they will work there. And I was doing some talk with some of our application people, and they say every Tuesday night there is an update of the central databases, and out in the country, the local libraries, or some of them at least, they're doing heavy data harvesting to update their local systems. So, okay, that was Wednesday. So, yeah, that was because of all this local library running harvesting of our central systems. And sometimes it was also Tuesday. Yeah, that was because of sometimes this update was delayed. So it was just, instead of running Wednesday, it was running Tuesday. So that was really clear. So case closed, customers was found guilty. Okay, well, you can put that way, but the root case was, of course, we needed our front-end web servers showed out to be really old hardware and needed a major upgrade. Okay, then we was going into this search monster case. Yeah, we were having problems at all times of days in intervals of 5 to sometimes 30 minutes. And some weeks, no problem at all. Back-end, front-end systems, didn't know. But zooming a bit out, there was really, here is right, right here is right a really clear correlation in again. And don't think that I was finding these correlations very fast. Sometimes I was using a lot of times an hours combining graph and looking around. So you're just here, and I'm sure just showing you the results here. But the correlation here, and okay, it's the yellow. We go down here. That's in search machine in Denmark. That's search machine in English. You can say, okay. So we go into the search. Looking here again. I was just zooming in, and it's more clear here. We have these huge, and we have the problem here along, really long, 5 minutes. That's really going to kill somebody. I don't think people will wait 5 minutes to look for this book. Okay. So, clear collection. Yep. Yep. Okay. So combining with this graph, I was putting under. So I couldn't have it on the same slide, so I kind of put it on this special. But I go back to the when we're seeing these peaks, it's correlating actually with what we were seeing on these search machines. That's specialized machines with an application which is only doing kind of finding, doing some search in the databases. And these search machines have an index which have to be updated, and that was what we were seeing here. So there was a update process running. Here you can see it with the low I/O. Well, it's not really low I/O, but you can see it here. And when in the end of every of these updates, there was a commit to this index or kind of database, I think. And you will see these peaks. And these peaks are really what putting down the system. The local updates process didn't, but the peaks was really making these other peaks we were seeing the search time. So I/O peaks correlate with application performance. So search server hardware was found guilty, updated also, and we also have to put really some really fast disk in it to really get this to work well. Okay, this is the last one. What's the time? Okay, not much time left. Okay, this is a big monster. It was also a big problem because I was using a lot of times to find out what's happening here. It was not so often, but problems again, performance problems. We were calling the Monday monster because people think it was on Mondays, but actually it was the whole week, so you couldn't say it was just here. Rather fast, I was finding some correlation with some of the other backend systems, what we call the DBC server, which is just a process. So we have the correlation here again. And also I was finding correlation with the system on our database server. And we were looking down at the logs, and the funny thing that was only most transaction was between 0 and 20 seconds. And then the rest was from 1 minute and more, and that means it was kind of timeout. So 25% of the transaction was timeout. How could that be? And we were searching and searching, talking with my database administrator. He didn't find any problems, and we're looking and looking, couldn't find anything. We did did a wrong run on this. Looked at other systems. Looking at we suspected some heavy batch jobs or something like that to be the problem behind this. And so I was going to look at these batch jobs. What I was actually missing a bit, it was to have some bar graph in this. So I tried to simulate that myself. Well, because I tried to put, what I actually was doing now also was, before I was just looking at I was putting up the monitoring of logs and things like that. I was just waiting when the things were clear and waiting for the problems to arise, and was then looking into problems when they arise. But it went into my mind that why not looking back? And that was what I was doing with these batch jobs and things like that. I was having the log file for a long time back. So actually I was just making some, I can show, yep. I was just making some jobs to a batch job, a script to get time from long time from data from time long back in time, and then I just with the Zabbix sender I could just send that into the database, and in that way I could also get time for. It's okay. You couldn't hear me before? Okay, we have to get it on again, sorry. Okay, what the problem I was facing also, why now you wake up, okay, was also how to show a problem, well, this is great, sorry. I was facing how to show this, how did it show how batch jobs were running, how did I visualize that? And here I was trying to do some with, okay, it's running this time, but well, this look really, well, I couldn't really use that for anything. So what I did was, in my script, I was simulating, kind of trying to simulate a bar graph. So I was sending the data here, which this is the input file to Zabbix sender, and I was zeroing the amount, and then this is the time, and I was seeing again. In this way, I kind of could get more. It was looking a bit like a bar graph in this way. It was more easy to look at least. What I was facing here was, well, at least I didn't find a correlation with the Monday. Well, hello. Well, sorry. Yet, but I was finding this big, heavy batch job running in daytime. Okay, it's really running in daytime, not in the night. And you can see here also, running every day in the daytime. That's not nice. So I was getting somebody to fix that, and after that we could see, okay, now it's running in nighttime. That's really nice. And also here you can see that. So at least something I was getting out of that. But certainly one morning I was more awakened than used to. I was finding the collation. I was finding, well, here we have the peaks again at the front end. We see the peaks this time at database server, and actually I was collating with the network I/O on what's some of the subsystem system, what was called the DBC server, and I was giving this time to some of to my database admin, and he was finding this transaction, which is okay, 5 minutes for one transaction, well, from one request. That's not nice. And our developer colleague was looking into it, and he was finding the guilty one. It was Mozart. Well, that's not really the explanation. The explanation is that a subtask in one of our search is to do a dynamic matching of all the references. It's just to do it more simple showing of the results. But the problem was that some of the medias had a lot of references, really heavy, and this searching, the matching is done by what we call a DBC server, and we find out that there was only running 4 instances of this DBC server. Okay, so which one was doing a search on Mozart or some other heavy references? It will block one of the instances, and nobody else could get searches in on this instance, and that explains why also 25 of the transactions was going bad. So the solution was simple. It was just to increase the amount of processes or instances of this database of this DBC server. That was really easy, and that was just it was because of the communication problem between development and our system people, so they didn't know this feature. Yep. So that was that. So get out there and explore what you can do. Any questions?
Zabbix 2.0 has own possibility to use JMX monitoring using that. Will you switch to it from Zapcat?
Yep. I'm testing it just right now. I compiled it yesterday, so, but, well.